let's say this is where we might do some more math. So let's copy this instead of just graphing stuff. Evaluate f times h. So this is a product. So this basically means f of 15 times h of 15. So this is going to be, plug in 15 in here, so I get the square root of 15 plus 1. And here I'm going to get h, so I plug in 15 here. 2 times 15 plus 1. This is 16, so square root of 16 is 4 times 1 plus, this is 30, 31. And I can't really do much with that, so 4 31s. 4 31. Find the intersection. Okay, so here, this is going to go from 0 to negative 6. So negative 6 to 0. Intersection means they both have to cross it. So maybe I'll draw this one. So usually how we do these is we'll draw the number line. And negative 6 is over here somewhere. Negative 4 is over here somewhere. And there's a 0 and there's a 6. So it's not drawn to scale, but it has all these points, right? So I'm going to use yellow here to do this line. This is from here. It's hard to see, but you'll see why I'm doing this in yellow in a little bit. And then blue is negative 4 circled in to 6 circled in. Now this is like that old commercial, Ziploc commercials or Glad, whatever. It was yellow and blue make green. You put these together like it was a Ziploc bag. And what you're going to get is it goes from right here to right here. This green part is where both blue and yellow are. Imagine squeezing it down. This is where you'd have the yellow part of the Ziploc bag. So this is negative 4 to 0. And where did it go? Okay. Negative 4 to 0 is that one. And it's bracket negative 4 to 0. All of them, all of these here. Okay, so we're going to find f plus g is f of x plus g of x is 4x plus 3 plus x squared minus x plus 2. This is f, this is g. Combine like terms. 4 minus 1 is 3x plus 5. F of x minus g of x is 4x plus 3 minus, I'm going to put this in parentheses because this negative has to distribute all the way through. So it's negative x squared. 4 plus 1 is 5x. 3 minus 2 is 1. F times g is going to be a FOIL 4x plus 3 times x squared minus x plus 2. So this is going to be 4x squared minus 4x squared. This is cubed. So a little ugly. Let me clean this up. This is 4x cubed minus 4x squared plus 8x. And I'm going to do the next one right underneath it, plus 3x squared. So now it's already like, you know, combined like terms already. Minus 3x plus 6. So 4x cubed minus x squared plus 5x plus 6. And last is division. And that's going to be, I don't know if we can do anything with that. F of x over g of x is 4x plus 3 over x squared minus x plus 2. Can we do anything with this? This is 4x plus 3. We can't really do anything here. This becomes x plus 1, x minus 2. Nope, not even that. Can't do anything here. So basically, this is our answer. Can't do anything with it. So let's see what we got here. The first one was x squared plus 3x, x squared plus 3x plus 5. And the next one was negative x squared plus 5x plus 1. The multiplication was 4x cubed minus x squared plus 5x plus 6. And the last one was 4x plus 3 divided by, we can't really do anything with it, so x squared minus x plus 2. A nice long composition. Now this one would might be a little hard, except this negative one is going to make it a lot easier. Okay, because we can start plugging in the number right away instead of having to carry around the x. My pen tablet just died, so let me plug it in and unplug it. So we have h of f of g of negative 1. Now g of negative 1 comes first, so that's going to be g of negative 1 is plug in a negative 1 right here, and this is going to become 25. That's just 25, and the square root of 25 is 5. So this is f of 5. F of 5 is, I plug in a 5 right here. This is going to become 6. 36 divided by 6 is, negative 36 divided by 6 is negative 6. So this is h of negative 6. The negative 6 comes over here. This is 2 times negative 6 is negative 12, plus 3 is negative 9. So just plug it in one each time, and that's how you do it. Find the domains here. The domains basically mean can anything go wrong? The only time things can go wrong is when you're dividing or taking a radical here. We're not doing any of them. So the domains are everything. In other words, no number that you plug in can go wrong here. If I was dividing by 0 at some point, that could go wrong. And we'll just keep this going. A one-to-one function means that it passes the horizontal line test. Now this is a line, right? And it's going to look like a slope of 8, right? It's going to look going up and down like this. So yeah, it's one-to-one because it's got a positive slope and it'll pass the horizontal line test. Something like a parabola would not pass the horizontal line test. Here, if we look at it, any horizontal line that I draw only touches it once. Now, if this was a parabola that came back up, it would touch it once and twice, but it's not doing that here. So this is a one-to-one function. If it's strictly increasing or strictly decreasing, it's going to be one-to-one. Because in order for it to touch itself again, it has to, change directions and come back up. Evaluate. Okay. Okay, so the first thing it wants us to do is do f of g of x. G of x is the square root of x plus 7. F, everywhere I see the square root, I'm going to plug it, the square, I'm going to plug it in. So it's square root of x plus 7 squared minus 7. The square and the square root just cancel out. And this is x. And that's what you want. G, to show that it's an inverse. G of f of x is g of x squared minus 7. I plug this inside of here. And so this becomes x squared minus 7 plus 7 inside the square root. The x becomes x squared minus 7. This is square root of x squared is x. So they're both x, which means they are inverses of each other. Now notice this domain is important here because I can't plug in anything less than negative 7 because this would be negative, and then that would negative. You can't take a negative radical. Are these inverses? Yes. Now the graph of an inverse function is the inverse image that you reflect it about this. So this negative 5, negative 5 stays here. This negative 4, 0 reflects all the way over here to 4, 0. Basically you switch the x and y value. So it's going to become 0, negative 4. This is going to become 2, 1. And this is going to become 4, 2, somewhere over here. So there's only one of these that looks like a reflection about the that axis, and it's this one. You can see that right here is the y equals x axis, and everything is reflected this way along the diagonal. And one last one. Find the inverse, the domain, the range, and the domain range of the inverse. Okay. So to find the inverse of any function, you switch. So this is f of x equals y equals this. You switch the x and y around, and then you solve for y. Now this one is almost trivial because to solve for y, you know, it's just going to be y equals 11 over x. So it is its own inverse. The domain and range. Now this is 11 times 1 over x. 1 over x is the base function here. The reciprocal, we know that that looks like this and like this. So, and this is just going to stretch it up a little bit, but the domain and range is everything but the 0. You can't plug in 0 here. You can never get 0 out of it. So, let's see where that is at. This is, the inverse is itself, 11 divided by x. Domain is everything but 0. The range is the same. I don't know if I can copy and paste this. Yep, I can. And we're all done with chapter 3.